So this is design session, and like I hope we can have like discussion to mic, so people remotely will also listen that. But I know it's also very hard to do the design session that way. So we already sorry everyone who's listening on YouTube. So it's about enhancing OS awareness of hardware security capabilities in Qubes OS, but it's not problem of Qubes OS only. So this is like a spoiler of the Michał Żygowski presentation, because this screenshot is a modified version of the Qubes OS report with some DRTM stuff. I know you cannot see that because it's too small, but believe me, there are additional features in this list than normally. And what's the case here? So lack of OS awareness about hardware security capabilities leads to the inability to evaluate and improve system security posture, and that's I guess like that statement which does not need any comment. The problem is that we don't have good mechanisms for that. It looks like everyone trying to implement that, and it's like a massive move in that direction. I was on a Linux Plumbers conference on Wednesday, and there was a lot of discussion about that. What's happened in other projects? So GNOME got the device security settings. It's based on LVFS HSI. KDE Plasma going in the same direction, having firmware security page like just the output of the LVS HSI. Qubes OS Security Report based partially on the HCL, but last time we discussed that it would be based on HSI. At that point, I agree with that statement, and today I disagree with that statement after 12 months, because HSI got a lot of assumptions, and maybe I will talk about that later. And we also got a call with Free Software Foundation, respective Freedom lawyers, like lawyer plus someone else from the Free Software Foundation. We tried with Thierry to explain needs and potential of such checks, but it's very hard to get traction in this and very hard to bring other people on the same level of knowledge about the hardware security. So nice interfaces which with some success exist in Linux kernel are sysfs, sysdevices, system CPU vulnerabilities. I guess this was like because of Spectre meltdown and all this other speculative execution, there was a lot of cooperation in the ecosystem how to expose this information, and that's why this is successful, and that's why this is good. Like people can just like do lscpu and see what kind of vulnerabilities they have, and if those are already mitigated because kernel provide that information. How trustworthy it is, we can ask Andrew Cooper tomorrow, or I don't know, maybe there are some expert from who know speculative execution vulnerabilities very well. Then we can also discuss about how good those, how trustworthy that output is. So maybe Marek, even you know, because I don't know. Yeah, so the point is that we have to secure our ecosystem, and I have to say that proprietary OSs are already there, and they already have mechanisms, and these mechanisms they have, and the methodology they're doing that we cannot re-implement because they have like heavy NDAs. They have like a layer of compatibility. On top of that is a set of testing which check that given features are exposed by hardware, so operating system can deliver certain security capabilities. But below that is a secret NDA communication with the vendors, where directly with the vendors they agree if given property was exposed by hardware. And every vendor in theory can do that in different way. Like in practice it happens, they're doing this in different way because they're treating that as value added of this vendor. Of course this changing, one of the things that changed that is this group on the bottom, the ARM system ARC. This is of course group behind the NDA, but some people have access to that group. And this is their security sub-team who tries to change that. There was presentation by Stuart Roder, our security architect, on the last Dasharo developers VPAP, and he essentially said that this group trying to maybe unify that a little bit, but for ARM ecosystem. There were other talks about that. I don't want to go too deep in that. This is not the lecture, but yeah. And there are also other problems like Like for example, how we will know in that we have SBAT, yeah, for security, UEFI secure boot revocation list. How in the operating system we will know correct SBAT was used with correct version, with correct certificate revocation list for UEFI secure boot. So if we will have your favorite IBV, your favorite is of course Tasharo, I know, but there are other people who got different favorite IBV, or they may use U-boot plus UEFI payload or other combination, and how we can make sure that Zen and Linux kernel will help to expose this hardware security properties for those combinations. It seems that they don't care. It seems that the only thing they care is proprietary UEFI implementation, and that's it. And they will talk only with that. So we have to think how to expose those interfaces and how operating system can claim something about security properties of the platform we're running on. Yeah, and LVS HSI, it is interesting. Yeah, yeah, it's yeah. I'm just like scrolling through my notes. The concept about LVS HSI is there is no consensus in community about this being the future of providing this information. What are the problems there? There is a spec which is not maintained. There are assumptions in the spec very close to x86 UEFI ecosystem based on the recommendation of the silicon vendor, which is not always good recommendation. Next thing is it relies on the consensus of UEFI forum, which we also not always agree with. And so that's why it is not really very community work. Yeah, I think it can be improved. I'm pretty sure that Richard is open to that. But on the other side, I heard from Richard that he don't have time for maintaining that specification. So this HSI host security ID, which this specification defines what level of security your hardware have. He has no time for that, and he considering passing that to Open Source Firmware Foundation. And the question is, like, I guess this may be good for that specification, but the question if it would be good. And of course, all the hypervisor-based OSs are ignored. Yeah, so proc, smocks, XCPNG, Qubes OS, like, because, and it's even harder in those OSs because there is hypervisor in between. But on the other side, there are proprietary ecosystems which work in very similar architecture, and they have solution for that. So if we want to compete, if we want to deliver solutions like that, we have to find a way. And I don't think there is a better forum than this, or similar communities which has a lot of experts to discuss this and to get this going. And that's my point. We need assessment. But otherwise, we cannot say what's the security posture of our device. This assessment have to be trustworthy. Come on. Maybe come here. It would be maybe better because I guess most of the answers you should provide, not me.
Yeah, so can you go back to the slide? This one. So this first point shows some interesting problem here, because sysfs and lscpu, proc, cpuinfo, etc. All provides a view from the point of that single VM. GNOME 0 is also a VM in Zen, which is different in Qubes OS. So that's another reason why just using FWPD, this HSI may not be the best way, because it's a view from a single.
So you already agree with me.
It's a view from a single VM, and there are two problems with that. One, it may not always see what's actually in the hardware. In that particular case, I think most things are visible, but maybe not all. But there is another point here, especially about some CPU vulnerabilities, that things that the Linux, the single VM has some things, some issue is mitigated or not, may not affect the whole system. We have different VMs and different mitigations at the hypervisor level. So, for example, VMC that one of those CPU bugs is mitigated in Linux. So maybe Linux will be able to like prevent data leaks between different processes in the same VM. But maybe it's not the case on the hypervisor level, and there are possible leaks between different VMs of the same system. Or the other way around. We have it mitigated between VMs, but not within a VM. So there are different levels, and it's also a bit different threat model. So you may be okay that your trusted VM, different processes in your trusted VM can like sniff data from other process in the same VM, because you don't have like all the processes there are trusted, and you don't hide stuff from one process to another in a single VM, but you care very much about leaking data to another VM of the system. Mm-hmm. So it's a bit different threat model.
Yeah, my point about, we will have Thierry in a second, but my point about the top one is not the methodology, because I'm not expert in speculative execution, so I cannot say if this is good. The outcome is very important for me, and the process they employed to achieve that outcome, because it's successful. So we should learn something from that. That's it.
Yeah, it's a follow-up question actually, because Xen is in the way. So after that, you have the kernel that is reporting what is supposed to be mitigated, but the information is not matching.
Yeah, so this is something that Linux is. This is actually one of the problem with this interface, because this interface does not talk to the hypervisor at all. It tries to see. It assumes it sees everything on the hardware, and in case of some of the mitigations in Xen, it's fully mitigated at the hypervisor level by simply either providing some extra mitigation, for example, when you switch context or switch between VMs, or simply disable some of the features in the CPU. And Linux may not be aware of that. So Linux see something that it's vulnerable to some of the issues, but it's actually mitigated on the Xen level, not a Linux level. So yeah, this is a problem with this interface. So
my question is, how can we mix those information so that we see that it's mitigated by Xen, so what Linux is reporting is actually false?
So this is something that Xen does report, but in a very inconvenient way. There is a message during Xen startup with all the list of mitigations applied. It's a text format. It's not machine readable. So yeah, then with I don't remember exact version, got an interface for reporting more of the information to the user space, especially to DOM0. Oops.
That's my
to DOM0. It's called hypervisor FS, Xen FS. I don't remember exactly, but it's an interface for providing machine-readable interface information. The speculative execution stuff is not there yet.
So we could merge those inside of a report at the end.
If I understood you correctly, you said that proprietary operating system already do some stuff. How does it look like there? Well, what are they actually reporting? Or
I don't know if I can be like we can talk like not unofficially about that. But the point is there is essentially what's already
Windows or something.
Yeah, sure. So what's already happened? What GNOME. What this report does is very similar to what's going on proprietary side, like very similar. Like there is some screen, there are some green stuff like that. So this is interface, but then behind what's going on, the difference is that for us to implement something like that, we need transparency from the bottom layer, from the hardware layer. We need some openness on the security features, spec or something, some public information about that. But the point is that vendors treating this as a value-added area, and all that is like most of that is proprietary. So
and every vendor has own idea how to expose this information.
Yes, yes, and then there is NDA between proprietary operating system vendor and the vendor and the hardware vendor, so that information can fly and they can agree that the properties, security properties are correct.
Do you have a specific example what feature we don't have like public interface, but
example of features? So SMI mitigation.
Okay.
Yeah. The RTM status. But
SMI mitigations, there are a special ACPI table called WSMT.
yes, there are some.
But it's just information that firmware provides you what mitigations it has applied
Okay.
for the SMI.
It is something at least, yeah.
Yes, there are some interfaces which are already existing, and there are some even UFI specification saying about way of extending this information, but this is not exactly always used. This is not standard way. Not everyone complies with that, and so on. We can select some group, like let's say we can agree that Dashar will comply with that, but we would like to. We don't want to be the one who does their own thing, because there will be yet another thing.
Yes, but I think we should start not from the other direction. Like see what information we would like to get, and see if there is some API for that or public or not.
Yeah.
Whatever.
So first three is like SMI, anti-vil mail stuff, TPM stuff. So TPM stuff is also very important. What TPM I have? Is it like PTT or like some weird FTPM with some weird profile? We have no idea what it complies to. Or this is DTPM. Like maybe what DTPM it is? Is it like something with ROCA, or maybe something with ROCA mitigated? Like I know that I'm going to I can go even more with the details, but we have to stop at some point. Yeah. The discussion on
this particular thing, I think Linux already reports.
But this is spread around various places. You see, CPU was gathered, like all the vulnerabilities, many different vulnerabilities in many different CPUs and families. But somehow they were able to organize themselves and put everything in one consistent place. Yeah.
Yes, but there are still some cases where the same issue in different models are reported differently. So it's not. Not fully consistent.
Okay.
It is one place,
so
but it's not.
Maybe I don't have enough knowledge about all the possible combinations.
Yeah.
Okay. So I know there is like on VPUB when I talk with Stuart, he kind of suggested, like, he don't know yet. He's still looking for feedback, but he kind of suggested that during the boot process there will be mandatory reporting of various things to the TPM or DICE or whatever, to say, okay, like this is enabled, and it will gather those information in a measured boot stuff, and then if this will be standard way for mandated by the ARM specification, for example, or then in that way you can attest that. You can attest that from the system, because you have standard to which you can comply. But this is like his very rough idea.
Yeah, some.
But in that way you can.
Some wish about the future.
Yeah, some wish. Yeah. I think we have to get there, because otherwise we will not be competitive.
Well, with Trench Boot, we can include some extra information, however you would like to collect them in the measurement. This is something we already, on a different topic, we do in anti-Mate. For example, we in addition to standard DRTM stuff, we also measure, for example, the looks header. Because it turns out it is relevant for the security of the boot process. So yeah, we add some extra thing to measurements, and yeah, we have the actually we have documentation.
Yes, sealing is extended with also PCR13, which is supposed to have the lux.
Yeah, exactly. And we have the not very formal, but we have documentation.
But it's
what
not.
is
But
in the-
you see, this is not going exactly into assessment. It's going. It's. You have to then gather that, and I don't know if you judge if this is a good state. There is also.
We don't have any kind of remote attestation.
Okay, you're going.
Yeah, so we don't like. You know, if you look at your local system, just looking at the PCR values is not very meaningful.
Yes, true.
Like without any context. But we have some information, for example, for all the features we use in Qubes specifically, including if you have TPM. On the page you've included. So yeah, we
will have a separate design session about the screen. But anyway, I guess Simon wants to say something. And
yeah, what I was more asking with the proprietary OS was, what are they actually exposing to the user? Like, do you have to just some green checkmark, or do you really get some report like you have this vulnerability with CVE something not mitigated?
Yes,
what are they actually exposing?
Yes, that's a very good point.
To the user.
So they goals are not trustworthiness of these reports. Yeah, they rely on the brand and their certification. So,
but this is mostly for compatibility, I guess.
I don't
is
know.
This
they market that as a security stuff.
Okay.
So, and then based on these green marks, they provide other certifications, other types of certification, like a higher level certification of the security of the system. And I think they don't care about trustworthiness of that, because everything is hooked to their brand.
Yeah, so they have agreement that they promise this is true. If not, they will be kicked out of the program or something, right?
Yes. On the other side, the operating system, there are researchers, and if someone will find out that this is false promise, then of course there is a lot of food in, and they lost in revenue or whatever. No?
Yeah, but I don't think the method to collect this information is one thing, and the other is how to present it and how to use this information. And like now we have like 5 check marks there, or 6, I don't remember exact number, but we can probably add 1 or 2 more, but definitely not 20 more, because will be useless for the user. For the user, I think we need to have some standard or whatever that is collected. Is it good or bad, or maybe is it like 4 levels, but not.
I guess we will talk about design. We will talk about design of that screen in separate session. I'm right more about assessment.
Yeah, okay. Then I'm going in the wrong direction, but I just wanted to state that, or firstly understand what kind of information can be exposed. For example, we have actionable information, like you have unapplied mitigations, and you should apply them. And this is something that should probably not be surfaced on the regular check marks thing, but maybe on the updater, some sort of information like, hey, there is actionable stuff there. And also kind of like surfacing some of the stuff that is static and per system and doesn't change through time on the HCL page.
Yeah, this is something that is getting more and more relevant right now, because there used to be a time where most microcode updates were some functional fixes, like there is this bug where some weird instruction can reset the system, and that's not great. But nowadays, most microcode updates are actually about security fixes in the CPU. So it's important the information whether your CPU still received microcode updates. And some CPUs are supported for 10 years, some are supported for 3 years, which is.
I had a hard time figuring out exactly like when they expired.
This is this information is quite hard to find. So there is this huge table with all the bugs and mitigations, and you have no information whether this particular is not CPU is not included because it's not applicable, or maybe it's out of support already or something. There is a page on Intel site where you have collected all the CPUs that are not supported anymore, but it's not exactly reassuring that, oh, I don't see my CPU on this page, so I guess it is supported, maybe. I didn't found any page like that on AMD, for example. So they have some security policy, which is very short text that, well, yes, we will provide security updates. That's all. Yeah. This is very relevant information, and we need to include this in our system. And I think this, this is something that is not changing. Like your CPU model is not changing. And I think this. HSI is not including this information also, because it's very hard to get.
Yeah, but you have also the UEFI security stuff.
Yeah.
So UEFI secure boot stuff. Yeah.
That's also.
That's something also. You're saying like you don't want to expose too much. Yeah.
Yes. Regarding the other security measures and features enabled, there is also the Microsoft HSTI, which I think we haven't mentioned, or do you have it on the presentation somewhere? It has it's a kind of set of bit fields that says about certain security features like UEFI secure boot, Intel boot guard, and stuff like that. So it reports the hardware security features
so you have
that are
Intel boot guard also another thing.
Maybe
so you very quickly go
into
number of security mitigations applied to current platforms to make them reasonably secure, or even maybe that is not reasonable enough, is big, and you just like going. This is like a spectrum. You're just going from, like, you are somewhere in the spectrum and you have no idea where you are in the spectrum.
Yeah, and for secure boot it gets even more tricky.
Yes.
So you have some firmware that is using secure boot is enabled, and you have whatever, and then.
But the databases are not correctly populated.
Yes, or maybe you have in your trusted key set one of the keys that were leaked or something. So those test keys something.
Yeah, but that's my point. That's my point. The problem is very very complex. But if we will not start moving, we will never get anywhere. Or we should at least even try to fail, because like failure is also learning. I know that there is no resources, like we are always lacking the resources for that. But I think it would be very hard to compete on the market with hardware without this assessment. This assessment is really needed. You're saying you want to have limited number of checks,
yes.
But then, and I agree for the UX perspective, but it has to be from one side. HSI goal was to give direction to buyer. Like, can I buy this?
Like 4 levels, if I remember correctly.
Yes.
There is
5 or 6 even maybe.
6.
Okay. No, 6 not.
No, I think
maybe 5.
0 to 4.
Yes,
so
yes, there is 0. Yeah, 0 to 4.
0 to 4. So.
This is. I just wanted to propose an idea. It's probably a bad idea, but this feels to me like it. I mean, we're talking about a relatively small niche, but maybe this would be a place for an organization / company to do the certification, or to have this kind of levels and then do the assessment, and then they output the final.
I already heard that one. Yes, that's one of the options that some people propose. I'm not sure if this is good.
Me neither. Just for the record.
The best would be if there is if the operating system expose that in a standardized way, which is implemented in community project like Linux and Zen. That's, in my opinion, the best way, because there are already companies there which would have to agree between each other to merge those patches, and that's important exercise. But I think that also in that way also can be blocked. No? Okay, that's we are end of time. We will talk about this topic also more from UX perspective on the session related to Qubes Security Report.
Okay.
Okay, thank you.